Jai Hind viewers, welcome to AKGEC Digital School. Today I am here, Pankaj Singh, Faculty of IT Department, going to deliver a video lecture on topic of direct memory access. It is relevant to computer organization and architecture. So now have a brief look about what is DMA and how it is useful in a machine to share a data between input-output devices and memory. Now we have a definition. So first we understand what is direct memory access and what its role in a machine. So first we know DMA. As the name defines, it is generally used to share data between memory and input-output devices. But how it is possible within a machine without using processor? As we know that in a machine all operations are executed with the help of processor. So how it is possible that without involving a processor we will share a data between memory and IO devices? As we know, generally the mostly operations are required to read and write operations. For example, if we give a input by using keyboard, for example, we are entering any account details or any relevant data. If we take an example of banking, then we generally enter the account number of the customer, and then we will get the detail of their personal details, their balance and other credit card and debit card details. So most time the operations is executed between the memory and the IO devices. IO devices here, input output devices, may be keyboard, mouse, printer or whatever that is required. So we can say scanner is also a input device by the help which we scan a barcode and the output is reflect over the screen against which. So why we need DMA and what is DMA? That is important to know here. So first we know what is DMA. As the name defines, it is a direct memory access concept, or we can say it is implemented at a hardware level so that we can easily implement and execute all the required operations. So all the operations within a machine is done by the help of DMA controller. So I am here to going to read a brief definition of DMA, and the whole work is done by the controller, or we can say processor also, DMA processor or DMA controller. So what is DMA controller? DMA controller is a hardware device that allow IO devices to direct access memory without less participation of processor. As the name defines, there is a no processor involvement, but actual no operation within machine is executed without the involvement of processor. So as I said earlier, we need to involve processor. So how these operations will execute? So processor is involved here once if we use DMA, but if we are not following DMA hardware or DMA concept, we need to involve processor at every IO operations that is executed between memory and IO devices. So how it's work, we will go in detail with their block architecture. So first we will know the basic things about DMA. As I said earlier, it is work between IO devices and memory without less participation of the processor. DMA control need the same old circuit of an interface to communicate with the CPU and IO devices. As if we involve this concept into a machine, that required the same interface communication as previously exists in a machine. Means we are not required to many manipulation in a term of hardware that can be implemented in a existing machine if we apply this concept. Okay, so this DMA controller consists 3 registers. Hopefully you all aware about the registers. Registers contain basic information or the temporary information about the operations. Like we have a address register. So as the name defines, it contains the address to specify the desired location in a memory, where we have to read or write operation that will get from the help of address register. It is generally abbreviated as AR. Likewise, DMA also have word count register, WCR. It contains the number of words to be transferred. Generally, a word is of 8 bit, or we can say 1 byte. The size is specified with the help of word count register. Similarly, we have control register CR. It contains all the control information, or we can say string, that operate all the operations relevant to the input, output, or memory that will execute is operated or controlled by the help of control register bits. It specifies the transfer mode, either it is synchronous or asynchronous. Or synchronous. So hopefully all of you understand the basic. So DMA is required to transfer data between IO devices and memory without the use of processor. And if we go to the technicality, we can say less participation of the processor. So how it is possible? We'll go with the help of block diagram. Now, in a given PPT, we have a block diagram of DMA circuit, in which we have the registers along with how these registers interact with the output data bus, and how the DMA request and DMA acknowledge. It is explained in a detail in given block diagram. As we see in a circuit, first we will know the abbreviation of all these. As written here, we have given control signals in a control logic like DS. It represents DMA select, as written here. Second is RS, that is used for register select. Along with, we have read operation and write operation. Apart from that, we have bus request, bus grant, and interrupt. What is bus request and bus grant? These signals, as we read about them in bus arbitration, these are required to access the bus for sharing the data over the network or between the devices. And what is interrupt? Interrupt is generated by two modes, that is generated by the machine or by the user. If we will go into detail, there are different type of interrupt, hardware interrupt, software interrupt, and vectored, non-vectored. These are not relevant here, but we should know about the basic interrupt policy here. So the interrupt is generated by the help of user, is a one type of interrupt, and the interrupt is generated by the machine to execute any specific program, that is a machine interrupt, or we can say software interrupt. So how it's work? We first know the, as I discussed, the abbreviation of all these. Along with the first IO device will request to the control logic, or that's also known as DMA controller, or we can say DMA processor, right? So first IO device will send a DMA request. Why it is sending DMA request? It is sent to share the data directly between memory and IO devices. IO devices may be a keyboard, mouse, or printer, whatever that is relevant at the time of operation. Similarly, when this request go to the control logic, and specifically if we talk about this, that's known as DMA controller. DMA controller take this request and process other instructions, or we can say control signals, as per the request of the IO devices. As DMA request, it will activate the DMA select. So how it will activate? First, it will send the interrupt to the processor. Main processor will take the interrupt by the help of interrupt signal. After that, it will find out that the buses is available to share a direct data between IO devices and memory. It will allocate DMA select. After that, the concern, as we know that simultaneously read or write what operation is requested by the IO devices, will assign to it, and the concerned operation will execute between IO devices. As I said earlier and discussed the registers, we have these registers in this mode here: address register, word count register and control register. I discussed earlier what they contain. Address register contain the address of the location where the read or write operation will perform. Along with it will contain the size of data that is transferred between memory and IO devices in term of word. As I said earlier, it will be in a one word here, 8-bit, or we can say 1 byte. Likewise, we have control register that control all the operations that is required to share the data over a buses or network in a synchronous or asynchronous mode. So we have also a data bus buffer where this data is temporarily held by the buffer. Why we required buffer? Because the speed of IO device and memory is mismatch. As we know, why we need buffer? When there is a speed mismatch or there is a no proper synchronization or syncing of data that is sent from one end to another. As we know, the speed of memory is faster as compared to the input devices, either it is keyboard or mouse. So hopefully you will understand all these operations or the circuit that are required within a control logic, or that's known as DMA controller. After that, the DMA select allocate to the control logic and it will send a DMA acknowledgement signal in last. That means processor allocate all the power to the DMA controller, or we can say control logic, to share the data between memory and IO devices. So it is a first, and that is a, we can say, confirmation signal that will transfer from processor to the DMA controller, and DMA controller send control to the IO devices so that they can communicate directly, right? And we use internal bus to share all this data over the network. What is bus? Bus generally carry data from one node to another. It is of three types: data, address and control, as we discuss in a first video lecture. Now the point will arise here, why we need DMA? It is one of the most important question. Why we need DMA and what is the use of DMA within a machine? I discussed earlier the definition of DMA and why we use DMA. I discuss here the first and important motive to use DMA here. As we know, how do we increase the speed of our existing machine, or how can we increase the speed and throughput of a machine? It is done by the given method. So to enhance the speed and throughput of a machine in term of data sharing, we use DMA. Okay, how it work? It overcome the communication time between IO devices and memory by excluding the processor using DMA control mechanism, in which the processor is involved once to take the request from the IO devices, and after that the control is hand over to the DMA controller, and DMA controller will work as a mini processor relevant to the input output operations. So why we need DMA? As we have 2 or 3 points. What is the basic reason and what are the issues that indulge DMA between a machine? As we know that the speed of processor is faster, and the magnetic disk, or we can say the magnetic memory, or as we know in a machine there are 3 parts: processor, memory and IO devices. IO means input output devices, and if we talk in term of speed and throughput, these 3 are different at different levels. The speed, highest speed here is processor, secondly memory, and third is IO devices. So I read the few points here why we use DMA. The transfer of data between fast storage device such as magnetic disk and memory is often limited by the speed of the processor. As I said in a previous statement, the speed of processor is faster as compared to memory. So to make it syncable and to save the time between sharing of input output data, we use DMA controller. The second, we have different data formats, means the peripheral devices that are connected to the machine, they have different formats. Example, keyboard have a different input format, likewise mouse have different input format. Similarly, barcode reader have different input format. It may take 8-bit input, it may take, I take just an example, 16-bit input, or barcode may take 20-bit input at a time. But the machine capability, as we know, that will process in a term of 32-bit or 64-bit. So how it is possible? First we will convert the required data into a given format or a given length. After that, that will be processed by the machine. So the different data format also create problem to sharing in a three-way pattern. What is three-way pattern? The first IO devices communicate to the processor, processor communicate to the memory, and the memory send data back to the processor, and processor hand over to the IO devices. It will take lot of time. So to save this time, we use DMA controller that work as a processor between IO devices, and only after one interaction all operation will execute between memory and IO devices. The third point, the IOP must structure data word from many different sources. For example, it may take necessary to take 4 bytes from an input device and pack them into a 32-bit word before the transfer to the memory. As this point I discussed earlier. Here, as I said, in term of bit and byte. Similarly, data are gathered in a IOP at a device rate and bit capacity while the CPU is executing its own program speed, or we can say rate. For example, what is here IOP? I give you the abbreviation, that is input output processor. What is input output processor? That will responsible for the all IO operations executed over the machines. So we can say all the IO devices is operated by the help of input output processor. IO processor have a IO interface, and IO interface have a IO port where all devices are connected. So I said earlier, the data transfer rate and bit capacity of machine in term of processor and storage device, memory and IO device, they have differ. So to make it comfortable to share the data in a same rate or in a required bit capacity, we use DMA to overcome this problem. So how this problem is overcome, we will discuss in a detail with the help of block diagram. So first we know how this architecture will work. Here we have a processor, we have a memory, and we have input output unit, or we can say devices. Within a machine, all operations of IO devices is operated by the help of IOP. So how this is possible? If we, there is one question arise here, if we are not using DMA, if we are not using DMA is communication between IO device or memory is possible? Answer is yes, but it will take lot of time. How it will execute? The IO device request read or write request sent to the processor. Processor send this request to the memory, and the first, second, memory revert back to the processor, and processor revert back to the IO devices by the help of acknowledgement along with data or operation what is required. But as we see in a given mechanism, it will take 4 operations, or we can say it will take 4 cycles to execute operation. First, it will send a request to the processor, processor send request to the memory, memory send detail to the processor, and processor send to the IO devices. It is a 3-step operations, or we can say a indirect communication is done between memory and IO devices. If we see here technically, there are only 2 devices involved, only memory and IO devices. If we connect all memory and IO devices directly and exclude this link, so we will, or we can say cycles to share the data. If we create a mechanism or any hardware that will allow direct communication between memory and IO devices, we can increase the speed and throughput of a machine without changing in there any hardware or software specification in terms of additional hardware and software specification. So, whole the process is done by the help of DMA. Hopefully, it is clear to all. So, to make this operations and sharing of data efficiently between machine, we will use here DMA. So, how DMA will work? DMA send the request to the processor, take the authentication and absolute all these operations in between and allocate direct operation between memory and IO devices. Hopefully, this mechanism will clear to all of you. So, how will it will work? We will exclude the 3-way communication. First, go to the processor, go to memory and go back and then revert back to the memory. So, how it will be done? It will be done only once. The request will send to the DMA controller, or we can say control logic. It will forward it to the processor, take the control of the data bus to share the data between memory and IO devices, and it will save the one cycle that will discuss in further slides known as cycle stealing. So, what is cycle stealing? We will save a one cycle in each operation so that we can directly provide communication between memory and IO devices. So, one cycle is saved, or we can say stealed between the all communication between processor, IO devices and memory. Now, we have a detailed block diagram of this process over the slide here. Hopefully, slide is clear to all of you, and it is explained with the help of DMA controller working. How it's work? It will work as we see in a given diagram. All the operations what a CPU contain or the CPU have write, these all operations a DMA control will have, like read, write, address line and data line. Likewise, a CPU have bus request and bus grant and interrupt input signals. Likewise, bus request, bus grant and interrupt DMA control also have. It have additionally 2 signals. What are these signals? First one is DMA select and second one is register select. So register will provide here the address of the location in a memory where data is read or write, and the DMA select will allocate, write or activate the DMA signal between processor and DMA controller. So how it will work, as we discussed in a previous example in this one. So first, the peripheral devices will send DMA request to the DMA controller. Second, I am writing in a very clean way here. First, the second interrupt request will go to the CPU for accessing this link. This link will access after few operations. When a machine get an interrupt, it will send a bus grant signal to the DMA controller, and it will disable bus request signal. As we discuss in a bus arbitration, the bus request signal will disable so that no other device will access the bus, because there is a data sharing between memory and IO devices. After that, when bus request signal is disabled, then all these it will send a DMA acknowledgement. After that, this link will activate all these relevant operations between memory and IO devices. What are these operations? Read, write, selection of any address, or sharing of data between input and output devices. As we see here, there is a data bus that connect directly between data of memory to the IO devices. IO devices here may be a keyboard, mouse, or output may be a printer. Okay, so in brief, I give an overview here. First, the IO devices will send a DMA request, machine will get the interrupt, it will send the, here we can say third, bus grant. Fourth, activate the bus request signal, disable the bus request signal so that no other device will access or request for bus. After that, it is a fifth, and this one is sixth, sharing of data between memory and IO devices. In a theoretical way, it is all this detail as I discuss here written in a theoretical way here. So all these operations is done here to share the data between memory and IO devices. That's also known as DMA transfer. Hopefully this topic is clear to all. Thank you.